So today we're going to talk about how to create a drawing for an assembly. We've already talked about how to create a drawing for a part. That was for communicating how to manufacture the part, how to machine it, what dimensions does it need to be. In this tutorial, we're going to talk about how to create a drawing for how to assemble your product. You know, what kind of procedures do you want? Where does what go where? What kind of process do you have? Do you plan to torque this or weld it or glue it or things like that? So this is called a BOM, a bill of material, BOM. And the way you read these is through the balloons. Okay, so you look at 16 and 16 tells you, all right, here's the print number, here's the location number, here's the description, here's the supplier and the number of values. So these are really important. You see these in a lot of job descriptions. It's like, does the engineer know how to read and create bill of materials? And they're really good for creating purchase orders as well. When you're designing, you're constantly iterating. You're importing parts, you're deleting parts. And when you create a bill of material, it's nice because you see everything work perfectly and you get a final result here with a bunch of numbers that you can just send to the finance department so they can put in a purchase order for buying the exact parts that you need. So there's no error with this. There's no real mistakes. Okay, so it's a very good way to work. And the nice thing with SolidWorks bill of materials is that everything intercommunicates. This part communicates with a model, communicates with a part drawing, so everything's interconnected and everything updates, which can save you a lot of work as opposed to drawing each line by hand just like they used to do during the drafting days or when they used to do with AutoCAD. So we're going to take the time now to create a drawing. There's a couple steps to this. The first one is that we got to create an explosion view with explosion sketch lines. Once we've done that on the assembly, we're going to import this on a drawing like you see here and start building the bill of material table. So that's going to be our game plan for today. So if we open the start file for this, we're going to get the toy that we built on the last tutorial. And what we got to do now is to create an explosion view. That's the first step before creating a bill of material. So this all lives over here. All right. Well, the first thing you probably want to do is make sure that it's locked. See how it's locked? I can't really rotate it. See, I have a configuration here where I can easily rotate it. But you don't want to do that because when you make it flexible like that, it could mess up your assembly. It could cause problems because some of this is kind of one way. So I encourage you to lock it. The way I did this is I just created a configuration that locks, that unsuppresses a tempo line. It just connects two planes. So that was just my way of doing it. But have a way to align it on an orthogonal angle, just like you see here. Once you've got that, you're ready to start your explosion view. And the way it works is really simple. All you do is you just select a piece, you move it, and it creates a step. Okay? So we're going to go ahead and explode this exactly like what you see in this chart here. It gives you the translate and the rotate. So when you decide to display an assembly view or an explosion view, it's important to kind of just take apart just a few pieces. Otherwise you'll get a cluster. A cluster of dust. If you just pick apart everything, it's going to be very confusing and you're not going to know how it comes together. So when you create these, you gotta use your judgment and look to see how can I just remove the least amount of pieces so that I communicate how everything comes together. And sometimes that can be challenging because sometimes you have sub-assemblies inside other sub-assemblies and you don't want to really create a bunch of like section views with detail views because you only have so much space on the drawing. So there's a bit of engineering behind like how you display this. You got to really think about how to make this very easy to read. But in this example, we're just going to follow what we see here. Okay, we're just going to pull apart a couple pieces and see where that takes us. So when you add the explosion steps, it's important to pick the pieces like they would be removed in real life. For instance, you would remove this before you remove that. So don't pull this one before you pull the bolt. Okay, so you got to pick something that's kind of realistic. So this bolt would remove So again, all you do is just you pick the bolt or the part, and then you just kind of you just move it away. You just eyeball it for now. We're gonna clean that up later. Okay. Again, these explosion steps, they have nothing to do with the mates. The mates and the explosion steps are two completely separate things. Like if I click OK here, the mates, they live in the design tree here. See, these are all the mates that we added on the previous lecture. The explosion view lives inside the configuration. You see this? These are all the explosion steps that I can modify at any time. So it's very important to only have one explosion view. Don't have like 5 or 10 because that's not good. A lot of students, they don't realize that the explosion view lives here, so they just keep adding an explosion view and then they get all kinds of problems. So it's important that you just stick to one, and if you ever need to modify, just hit edit feature. Alright, so now I'm going to work on the handle here. Now this one's a little bit more challenging because see, it's kind of like at an angle. If I try to move it in this direction, you know, it's not really what I want. And if I try to move it up, it's really not what I want. So to do this one, to move this one on its axes, you gotta first select the bolt. Then you got this box here, okay? You gotta pick a concentric entity, an entity that's axial to this bolt, which is this. And you see what happened in this arrow? It changed. It switched to its axial position. So then when you have that, you can move it out. Alright, so let me do that again. You pick the piece, you pick this box, you pick a feature that's concentric, and then you move the object. So if you don't remember how to do that, again, you're more than welcome then to replay the video, but you can also watch the documentation. Step 1, Step 2, Step 3, Step 4. Okay? So now that we have some of the major pieces exploded, we're going to kind of clean this up a bit. What I'm going to do is just double click the step, and I'm just going to kind of eyeball and round this off just to stay clean. Okay, I'm going to hit apply done. See, it says 1.2757. I don't really like that. I'm just going to round off to 1, hit apply done. Then I'm going to go here, and I don't like that 3.26 whatever, so I'm just going to hit apply done. Okay, so I'm just going to do that for every step. It's always good to have a clean workflow like that. Going to round that up. This is the nut. I'm going to actually add an angle here, maybe 2,000 degrees. Just because when you rotate it, when you animate it, it will rotate. Okay, so I'm going to put that here, and I'm going to put 2,000 degrees. Okay, so here are all my steps. They're all rounded off. They're all clean. So now to kind of see what we got here, we can go back to the root, and we can hit collapse, and we can hit explode. And again, these explosion steps have nothing to do with the mates. They don't delete or insert any of them. We can even animate collapse if we want to. As you can see how it's spinning? See how those nuts are spinning? That's because I added that angle. But we can see it, yeah, we can see it assemble and disassemble. So there you have it, okay? You can even save this animation if you want. Maybe you want to show how it comes together. So you can do that as well. So the next step to this is to add the explosion sketch lines. You see these lines here? These are used to show the axes of assembly, and it's really important to include them because it really adds a lot of clarity to your bill of material. So to insert them, you gotta go back into explode mode, and then you gotta add them through the explode line sketch button. And all you gotta do is really just select the endpoint. Select the endpoint of one piece, and it goes through the hole, through the housing, and out into the nut. Okay, and that's how you do this. So let me do that again. Pick one endpoint, and then insert it all the way through this piece. So when you do this, see this arrow? Make sure it's pointing towards the axes of assembly. If you point it away, like right now I pointed it away, look at what you get. You get some weird detour, right? See this arrow? It's trying to figure out how to get there by doing this detour, so that's not good. You got to change the arrow, make sure it's pointing towards the center. So that's the main tip I can give about this. See, the arrow's not pointing correctly. It's got to point inside. It's going to go all the way through and down to the gear there. Click OK. And then finally, there's one for the handle. Okay, so it's going to be the handle here, all the way through the universal joint. And there it is. So there's all the sketch lines. Okay, so let's take a look. So again, it's very important to pick the endpoints. Don't create a bunch of intermittent sketch lines. Do one continuous line like what you see here. Okay, so now we're actually done setting up this assembly file. Okay, we created the explosion view, we created the sketch lines. Now we're going to save this, okay, as an assembly, as it already is. Now that it's all set up, we're going to start creating a drawing, creating the bill of material. So I'm just going to create a drawing, and we're going to use the CSU template. And we're going to browse for this file that we created. Alright. So now I'm just going to create a projection. And I'm going to try to follow the projected view on the diagram here. So we have side view and isometric. So yeah, it looks pretty good. Just like that. And then this is going to be 1/2. And 1/2 for this one as well. I probably should use sheet scale of 1/2. I shouldn't customize the scale for each of them, but just to stay consistent. Also, did you notice how this is the same nut for the assembly? That's really good practice. When you design, use the same hardware throughout your machine. Don't use crazy values everywhere, because that just makes it difficult. So I mean, even just for maintenance, you know, let's say something broke in your house, you don't want to spend hours trying to find what kind of thread it was. Think of how nice it'd be if everything was the same. It's like, oh look, it fits perfectly. You didn't have to spend any time searching for it. So now I'm just gonna clean this up a bit. So I want to remove the tangent edges, and I want to remove the construction lines, hide all types. That looks really, yeah, that looks pretty good. This one is actually not in the exploded state. So I'm going to say show in unexploded state. There's like 3 different ways to do that. I'm just going to show you one way. Just show collapsed. And then I'm going to remove, hide tangent edges. Okay, so that looks good. I don't like these lines though, so I'm going to hit rebuild. There you go. I hit the rebuild. Sometimes it needs a little refresh like that. And I'm just going to update the template. Alright, I'm just going to put my name. And then you can put your ID there. And I'm going to put the date and the scale. So this should populate the numbers on the bottom. Alright. So that looks pretty good. But we still got some work to do. We got to add the balloons and we got to add the bill of material. So to add the bill of material, you got to select a view first. If you don't select a view, it's not going to know what to do, because there could be multiple views on a drawing. You could have 10 different models and assemblies. So the software needs to know what you're referencing. So I'm going to insert a table, and it's a bill of material. So let's talk a little bit about these properties. The first property here is talking about BOM type. Top level means that you just display the assembly names. Part means you display all the nested parts of those sub-assemblies. So remember, when I say when you design a machine, you don't just insert a bunch of parts in one assembly. You insert master assembly. You insert sub-assemblies in a master assembly. Like I said, like when I design a machine, I insert a sub-assembly of the electrical panel, a sub-assembly of the hydraulics. Okay, so when you create this bill of material, you have the option to either display all the nested parts in the sub-assemblies or display just the sub-assembly name. So I highly encourage you to just stick to this, to the top level only. Then this configuration one is pretty cool here. I actually have a good example of that here. A lot of times when you have 2 models that are very similar to each other, you don't want to create a separate drawing. You want to create one drawing for multiple products, and the way you can get away with that is by inserting a bunch of uh, columns. Okay, so think about it. Let's say you have one product and it's got 2 electrodes, another one's got 3. You don't want to create a whole new drawing and copy all this stuff just to say there's 2 or 3. So what you do is you turn on configurations, and it's going to say 2 and 0, and in this way you communicate 2 pretty complicated assemblies in one shot. So that's what that is. You can say, hey, to add a column of these other configurations that I inserted on my model. This is just for the numbering where it starts with the balloons. It's not too important. But anyways, that's kind of what you do. You insert that. Usually you're supposed to snap it to the corner. That would probably be a better way to do this. There you go. And now we're ready to add and customize the columns. Alright, so the first column I'm going to add is going to be the print number. So really what you do is you click this blue banner. This is a custom property. It's because it's a property I inserted in each model by hand. And we're going to select print number. It detected that at least one of the parts has a property called print number. And look at that. Did you see me type anything? It was all generated. That's why we learn to create properties on the models by themselves. Okay, because this is a clean way to work. It extracts that information as opposed to me hard typing all this stuff. That's not how you want to do this. You want to add the properties, right? We right click, we open assembly, we open part. Okay, we go file, properties. Because I typed these in exactly, it was able to fetch them on my drawing. So that's why we learned how to do that. Same with the template here. Same with all that stuff. Okay, the next item, I'm going to insert left. Oh, and by the way, print number is used for referencing on machining drawings and shop assemblies and things like that. So it's a really good code to use to reference. Alright, the next one's going to be the location number. So the location number is kind of talking about where you plan to save spare parts. So to answer that question, you gotta figure out how perishable your machine is, or how perishable your parts is. So for example, on a car, an oil filter is more perishable than your spark plug, right? The oil filter needs to be changed maybe every 5,000 miles. Spark plugs every 100,000 miles. So for the oil filter, you might want to store spare parts in the tool crib. The tool crib is a place where operators can easily access, but the real estate is expensive because a lot of times it's in the middle of the shop floor. So you try not to put too many spare parts there. But something like a motor or a spark plug, something that's gonna wear out less, you gotta spec that in like a maintenance warehouse. This is called MRO, maintenance, repair, and operations. So this is the higher ticket items, things that you don't need to replace as often. And then other times when there's a piece that I probably will never need to replace, like this frame here, I just spec an e-print, an electronic print. So if someone wants a new one, they at least have access to the print so they can machine it. I usually talk to the MRO maintenance tech and I tell them, okay, here are some e-prints, here are their numbers, and I say, all right, if anyone in the future needs a reference to this drawing, just tell them this code and go to the maintenance MRO department to take care of that. Because again, you gotta think about it, the designer is not always the person that supports your product. A lot of times these machines are designed to last for 30 years and you don't really touch it after the handoff. So you got to think long term. You got to think about who's going to maintain that. Will they know what they're doing? Will they have access to all that information? So again, like a good designer, someone who can think about all these pieces. It's not just, oh, here's my product and it works and it's all right. You got to think about all these little details when you design. Because once you design, really, there's not a lot of going back. It's a one-way streak. When you design, there it is. People are going to have to deal with its issues for the next 20 or 30 years, and that's that until they get the budget to buy a new one, buy one that's a little faster or more efficient. So Really think about this a lot during the design phase. Spend more time planning so you spend less time executing. I think it's a good way to go. So the next one is just a description. Okay, it should be pretty self-explanatory. I do have a common nomenclature for fasteners. I try to stay consistent with that. You're welcome to use your own, but just try to be consistent. Okay, try to talk about some of the common parameters like the diameter, the length, material, and things like that, because when you are going to use a lot of bolts on your designs, you want to have some sort of system for that. Alright, I'm going to add just one more column here. This one's going to be supplier. And really, supplier doesn't make sense for custom hardware because there could be many different machine shops out there that can do the job. But this is more relevant for off-the-shelf hardware. Okay, let's say this wears out. Think of how easy it is for me to just type this number on the catalog and buy a new one. So I think supplier makes a lot more sense for off-the-shelf hardware. But it's always good to include that on your bill of material. Another thing I like to point out about this bill of material is that sometimes these numbers are not correct. You have to double check. Like for example, if you look at the universal joint, when you buy these, it comes as one piece. But here it's saying there's two. And you don't want to buy two if you only need one. You don't want to collect garbage in your desk. So sometimes you have to bypass this, okay? The only reason I have two is because I needed to create the animation that I wanted to create. So sometimes you have to bypass this. You double click it, break the link, and type in what you want. I don't encourage doing this because now you lose the reference. You lose the link to the actual quantity. But sometimes you have to do that to maintain a realistic bill of material so that when you submit the purchase order, you submit the right amount. So now we're ready to add the balloons. That's on the annotations tab, and you can hit the auto balloon all you want, just like there's an auto dimensioning button. But I don't like doing that because it ends up being more work to fix than to just do it from scratch. So I encourage you to just create each balloon from scratch. I feel like that's much more efficient way to use your time. But now you got to know where to put the balloon. So here's what I do. I go through each list, each item, and I look to see what's purple, and then I put a balloon there. So you don't want to have a missing balloon. Okay, that's not good. Just like you don't want to have a missing dimension. But it's okay if you put two balloons. Like if you put one here and then you put one here too, that's okay. But don't have two balloons on the same part, on the same view. It's okay if it's on a different view, but don't have it on the same view. So I try to look for a location that is easy to read. That's what I do when I add these balloons. See, like sometimes I feel like this is easier to read here than it is on the isometric, so this is why I'm putting it there. So it's all about clarity. See, now this one I got kind of lucky because I don't have access to 11, but I do have a little access point here. That's really good because otherwise I'd have to kind of re-engineer this. Maybe I need another projection. Maybe I need to adjust my explosion view. Okay, so you don't want to have a part completely hidden. It's got to be accessible in at least one location. Okay, so now that I've inserted all the balloons where they're supposed to be, I'm just cleaning this up a bit. After you've cleaned things up, try to reduce the length of the arrows. Try to not put balloons inside the assembly. Okay, try not to have duplicate balloons like we talked about. Again, just try to maintain the overall clarity of this. But when you're done, you can then go ahead and add a note, okay, just like you would any other note. You just type it in, you hit enter, you have your editor just like any text program, and then you can hit File, Save As, Save As, and what you'll get is the final product that you see here. So you got your notes, you got your table, you got your balloons all cleaned up. Again, I really do like the arrows, and I like how the length is reduced. It's all dressed up, it's clean. You got your sketch lines, so it all looks pretty good. One last thing I want to talk about are the notes. Okay, let's talk about that. On a part drawing, you had to talk about notes that are relevant for the machining, like make sure to code it, make sure to break the sharp corners, make sure to add an allowance for this datum feature. In an assembly drawing, you gotta add notes that are relevant to the assembly. So, for example, put a max torque requirement on plastic threads so they don't strip. Make sure to clean the product of particulate. Sometimes I've had to design watchmaking products. I mean, really small pieces of geometries, and because of that, I needed to design the tooling just to assemble and disassemble it. So that is sometimes what you got to do. You got to not only design the product, but also design the equipment to assemble it. And that's not a good thing to do, because let's say you run out of these. Where do you go? You can't go to Home Depot to buy one of these. But sometimes you have no choice, because some things limit you to the point where there is no off-the-shelf supplier that can provide what you need. So some of the others I've noticed over the years is some things like labeling, tagging, tie wrapping, using barbed inserts in pneumatic tubes so they don't explode in the shop. So that's happened on a couple occasions. So you'd hear this really loud pow, and the tubes would swing around. And ever since then, they'd say insert barbed collars inside pneumatic tubes to provide more compression. Pastes for electroconductivity and lubrication. Okay, so those are some of the more common assembly notes. But again, in the end, make sure to do save as a PDF, because we talked about that on the last lecture. We talked about how there's no directory referencing with a PDF. You can save this and it will be saved forever. Okay, you're not gonna lose the model. See, you're not gonna get. See, if I open the end, if I move the location of the model, look what I get. You see, you get a bunch of empty models, and this happens all the time. You break the link of a directory, this is what you get, and it becomes a pain to fix. So this is why a PDF is really clean. It's a clean final product. So that concludes the lecture on assembly drawings. And again, understanding how to do a part drawing and an assembly drawing is one of the core skill sets of mechanical engineering.